This question asks us to explain how to use composition of functions to check to see if an inverse function is correct. So for example, let's say we stated that f of x is 2x minus 5, and we think that f inverse of x is x plus 5 over 2. How do we check? Well, we examine f circle f inverse of x, which of course is f of f inverse of x, which is f of x plus 5 over 2. What does f do? 2 times something minus 5. 2 times something minus 5. But the something, f of x is 2x minus 5. F of something, the something is x plus 5 over 2. Well, you notice 2 over 2 divides out, and I get x plus 5 minus 5. X plus 5 minus 5 is x. That makes me happy, okay? F circle f inverse of x was x. So f inverse does one thing, f undoes it so that you get back what you started with. And that's one thing that should happen when you check to see if the inverse is correct. You can compose the two functions. We should also compose it the other way for an additional check. F of x is 2x minus 5, and we think f inverse of x is x plus 5 over 2. Now, the first time we did f circle f inverse. This time, let's do f inverse circle f of x and see if the resulting thing that comes back is x. So this is f inverse of f of x, which is f inverse of f of x is 2x minus 5. F inverse is supposed to be something plus 5 over 2. F inverse of something is something plus 5 over 2. So the something this time is 2x minus 5. So I get 2x minus 5 plus 5 over 2. Which is 2x over 2. Which is x, which also makes me happy. So a quick answer to the question again, how can we use composition of functions to see if an inverse is correct? What do we need to happen? Well, the quick answer to that question is the following. If f circle f inverse of x equals x, and if f inverse circle f of x equals x, then we know that the inverse has been determined correctly. Okay.